In this presentation, we're going to address an issue which confronts many auto repair technicians, DIY, do-it-yourself folks, owners of small repair shops, and that issue is the reuse of automotive modules. As I'm sure you're aware, if you have a vehicle that has a failed module, many times you just can't go to a salvage yard and pull an identical module from a wrecked vehicle and then install it in the vehicle with which you are currently working, trying to fix. And what we want to discuss in this presentation is why that is, and also the use of the Andromeda Research Automotive Kit to allow you to circumvent that, or basically get around the issue of a locked or defective, or in other words, a module which you otherwise wouldn't be able to install in a car. So if you look at a vehicle module, in this case, this is a PCM out of a 2015 3.2 liter Jeep Cherokee. Why can't you put this into another identical car? Well, you can't, because the module has been programmed so that the information that's in this module is specific to the vehicle from which the module was removed. Okay, so if this came out of a wrecked car, you wouldn't be able to install it in the car on which you are working. So why is that? Well, first thing I want to do before we go down that path is let's talk about how a vehicle module, and pretty much they are all very similar in how they work, even though they have totally different functions. In this case, we've got a PCM, powertrain control module. But you can have something as simple as a electric parking brake module, or a window module, or a door module. What is it that they all have in common? Well, they're all on the car's network. And if a module is not programmed for a specific vehicle, meaning that the information in the module doesn't match the information that's in all of the other modules, then it's going to be rejected by the module community. And that means that when one module sends a command to another module, the module to which the command was sent will not respond. So what I want to do is go over fundamental operation of how modules work, and then we will address what you can do to bypass that or get around that. Okay, what you see here is my crude attempt at art when it comes to drawing a vehicle module. Okay. On the left-hand side here, we have basically the bus. This is CAN bus in most vehicles, and this is how the module communicates with all of the other modules that are connected together in the vehicle. And I guess if you're interested in the CAN bus, there are a lot of videos on CAN bus. And I'm not going to go into how CAN bus works. It's basically it's like the internet of cars. Okay, all of the modules communicate over CAN bus, and there are plenty of videos which explain how CAN bus works, all the way down to addressing and all of the different features of the protocol. But nonetheless, the CAN bus is how the modules communicate. Okay. Let's go over why automotive engineers like modules. Okay. Prior to the introduction of intelligence, meaning computer control in a variety of vehicle applications, The only way that an engineer had of controlling something was to have a wire go from a switch to whatever the destination point was, like a motor or a light or whatever, okay? There wasn't any way to cause an action to happen other than to basically close the circuit. And although that was really simple, it was also resulted in lots and lots of wires running around inside the car, which added for lots and lots of weight. Okay, and it also meant that adding additional features and complexity to a car would be could be very cost prohibitive. Okay, so with the advent and introduction of what I'm going to call intelligence, and by intelligence I just mean little computers. Okay, a little computer to control whatever it is that the engineer wants to control. He can just take that little computer, he can design it into a module, and that's all he needs to do. Okay, now there's much, much more to that than just the introduction of a little computer. Somebody has to program the computer, and they have to decide what the computer is going to do, and they have to decide what things are going to be hooked to the computer, and all of that. But in reality, you take that functionality and you put it on a circuit assembly. You hook it up to the CAN bus, you bring in power, okay, up here we have power, and you hook it up to all the inputs and outputs that are going to be controlled by that module. And at that point you're done, okay? Most of these things over here are going to be local to the module, okay? And I've just drawn some things like switches, and this is supposed to, this is a sensor, and this is a what was I drawing there? Oh, it's an M for motor. This is a light bulb. This is an LED. Okay, so all of these things are going to be controlled by this little thing in the middle here called a microcontroller. All right, and a microcontroller is the little computer that controls the functions of the module. All right, so think about the weight that's saved. What do you need to run this module? You need to have the CAN bus, which is basically CAN high, CAN low, and a ground reference. You need to have power, which is 2 wires. But most of these things are local to what the module controls. Let's say this is a door module, okay? You have power that's going to go to it. All of the switches, the lock, the unlock, window controls, all of that are going to be wires that run from the module to those local connections in the door. So you don't have to have this massive bundle of wires. You've got everything controlled by the little computer that's in the module. Okay, so that means that, let's say that one of the switches here happens to be, put the passenger window down. Let's say this module is in the driver's door. So you want to put the passenger window down or lock the passenger door or whatever. So one of these switches is going to do that function. So you press the switch, the microcontroller sees the switch close, a little program in the microcontroller is scanning the switches and doing all of that stuff. And it says, oh, the switch is closed. I'm going to send the command over the CAN bus to the other door module, and that door module is going to receive the command, and it's going to do what I'm telling it to do, which in this case happens to be, let's say, lock the door. Okay, so all that had to happen was this module, the little microcontroller, little computer in this module, sends a command over the bus, over the car's network, and that command is seen by all of the other modules in the car. But they are not going to respond to it because that command is going to what's called an address, a specific address, and that specific address in this case is going to be the passenger door module. Okay, so the passenger door module then receives the command from the driver door module to lock the door. It interprets it, looks at the data that it's required to analyze, and click, the passenger door locks. So basically you had power and the CAN bus and this module, and that's all you needed in the driver's door in order to make this work. And you have another module similar to it in the passenger door. That's all you needed in that door in order to have that happen. So you can see that this is really, really from the position of an automotive engineer, this gives them so much flexibility to add all kinds of features to vehicles that would have otherwise, before the introduction of the intelligence from the microcontroller, would have been extremely difficult to accomplish. Okay, so now let's take our scenario a little bit farther. Let's just go ahead and continue to use the driver and passenger door example. Let's say that one day the driver gets in and he wants to put the passenger window down, put the passenger door window down. So he pushes the switch on his door, which corresponds to the function of putting the passenger window down, but nothing happens. Passenger window doesn't go down. Okay, well, why? Well, there's a variety of reasons. Could be everything from the motor in the passenger door that runs the window failed. It also could be that the transistor that turns on the motor, if it's a transistor or relay, that's in the module in the passenger door has failed, or lots of things. Could be the microcontroller has stopped communicating. Could be a broken wire. Could be a lot of things. But let's assume that it's something in the module itself. Okay, let's assume that the transistor that was supposed to cause the motor to energize and roll the window down, has failed. Okay, well, if you have a scan tool, which is bidirectional meaning that you can send commands over the car's network, not just read things, OBD codes from the car's network. If you have a bidirectional scan tool and you plug it into the diagnostic port on the vehicle, then you should be able to send a command, assuming that your scan tool supports the commands for this particular vehicle with which you're working. You should be able to send a command over to the module and cause the window to go down. And by the way, when you connect your tool to the diagnostic port on the car, your tool just becomes another module on the car's network. So that, assuming that the people that wrote the code that's in your tool got everything right, you can send commands to modules, you can receive information from modules, and that's why when you connect your tool and you say scan, basically do a global scan of the vehicle, it'll sit there and crank away and crank away and crank away and crank away, and you'll see the results from all of the modules with which the tool has access. It'll tell you whether or not any of those modules have a failure condition. Now that does not necessarily mean that the module itself is working, because the module could report everything is fine, but if the transistors failed in the module that controls, a light or a motor, the module isn't going to know that. Okay, it won't know that. You won't know that until you actually command the module to energize the transistor, which will energize the motor. Okay, so a lot of times, those tools, even though they're really great and they're wonderful in their sophistication, they won't tell you if a module itself, internally, its electronics, have failed. It will tell you whether or not the module is communicating, but it will not tell you if there's an external issue. But if you have a bidirectional tool, then you can send commands over to the module instructing it to do something, and then from that point you can determine that indeed the module, even though it's communicating, is not able to control whatever it is that it's supposed to control. Okay, well, let's assume in this case that you've hooked up your scan tool, your bidirectional scan tool, you've sent a command over to the passenger door module, and you've commanded it to put the window down, and the window doesn't go down. Okay, well, at that point you probably say to yourself, well, module is probably bad. So what do? Well, you can go to, depending upon whether or not you can actually get another module, the dealer and or some other parts source, and purchase a replacement module and install that module in the vehicle, take the door apart, take the old module out, put the new module in, and in the event that, I mean, I'm assuming this is a new module, brand new module. Okay, well, unless it's a plug and play module, okay, meaning that you don't have to give the module any kind of information. It's already programmed with its CAN bus address, and that's all that it really needs. Everything else, the program running in the microcontroller is the same, so you don't have to do any programming. That's a plug and play module, and if you happen to have a plug and play module, then that's great, because you don't have to do anything. Just install it and you're done. But if you don't, if you install the module and then you find out that the module has to be programmed to the car, okay, well, what does that mean? Okay, if the module has to be programmed to the car, it means that that module has to have vehicle-specific information programmed into it in order for the module to communicate, to live in the module community with all of the other modules in the car. Okay, so what kind of information is placed in a module that would cause it to only be accepted by the other modules in the car? Okay, well, normally, or in many cases, it's something as simple as the VIN, okay, the vehicle identification number. And if you don't have a factory tool or a third-party tool that is able to program the VIN into the module, well, if it's a new module, you're going to have to take it to a dealer and have them do that for you, because they're going to have, you know, the factory tool in order to accomplish that. All right, well, if you have to program the VIN into your new module, where does the VIN actually reside in the module? Okay, and how does it get there? All right, well, the VIN gets there via your, well, let's not say your, let's say the dealer's tool, the dealer's system, and they plug into the diagnostic port, and they send a command over to the module, and they'll have to either enter the VIN, or the tool will automatically extract the VIN from another module in the car, and then they will write that VIN into memory of the new module. And once the VIN is written, then that module, its VIN will match the VINs that are stored on any other module, and at that point you're done. Okay, the VIN is there, and the module will now communicate, and you know, you'll check it all out and make sure all the functions work correctly, and you're done. But how does I mean, the memory in the module that holds the VIN, okay, well, what is that memory? That memory is what is called EEPROM. Okay, and if you want to know more about EEPROM, we have a video on EEPROM work that we've done. But let me just draw. I mean, the EEPROM memory is a memory that doesn't forget when power is removed. And when you install a module where there's the VIN has to be programmed, the EEPROM where the data would be stored, it's going to be blank at that spot. Okay, and the EEPROM, it's going to be a little 8-pin part, and let's just draw it right here. Okay, that's the EEPROM. Now, how does the data get into the EEPROM? Okay, well, the microcontroller is sitting here and it's running its program. Well, one of the commands that the microcontroller can perform is write data to the EEPROM. All right, so when you communicate with the module, with your tool, and you're marrying the module to the car, your tool is going to tell the microcontroller, hey, here comes the VIN, and I want you to write the VIN into the EEPROM. So it's going to write the VIN into the EEPROM. And then the EEPROM will continue to hold the VIN. So at that point, the module has been programmed to the car. Now, this is where some of the manufacturers have, they don't want you to go and get a used module from another vehicle. Why? Well, because they don't want you to, they want to sell you a new module. And that's great, if you have the money to go buy a new module and you got the tool to program the module, or you want to pay the dealer to program the module, then you get a new module, you put it in the car, you get it programmed, and everything is fine. Okay, well, what if the dealer or the manufacturer, there's a chip shortage or some other manufacturing problem, and there's no modules available? Okay, well, this is where, gosh, maybe I could just put a used module in there. Wrong. Okay? Because a lot of the tools, especially dealer tools, will not program a used module. Why? Because they want you to buy a new module. And if they'll say, well, you can't, it's already programmed. And the way that they tell it it's already programmed is they'll send the command over to the module and say, is there a VIN already programmed into this module? Well, sure enough, because it came out of another car. Oh, well, if there's a VIN already programmed into it, then sorry, you can't have that VIN changed. So this module is not usable. Okay, well, at that point, you're kind of screwed, because the tool, which has to use the car's network in order to accomplish writing the data, okay, to the EEPROM, will not let you do that. Because, even if you know the command to write the data, let's say that your tool knows what it's supposed to send to the module in order to write the data into the EEPROM. All right, well, the microcontroller, when it gets the command to write the data into the EEPROM, regardless of the tool, the microcontroller will look in advance at the data that's in the EEPROM and say, VIN's already there. I'm not going to do it. So at that point, no matter what you hook to the diagnostic port, no matter what your tool is supposed to be able to do, if the microcontroller refuses to execute the right data, it refuses to write the data to the EEPROM, at that point, you are locked out, and that module cannot be used. Well, the module cannot be used if you're trying to program it from the diagnostic port. But there's another way. This is called EEPROM work. Okay, and EEPROM work is what the Andromeda Research Automotive Kits let you do. It's different because most automotive technicians, DIYers, service shops look at modules as just parts. If the part doesn't work, or if the part's locked, they can't use it. Well, that's true if the only tool you have communicates via the diagnostic port. But if you take the time to learn about EEPROM work, then you have another path. You have a path where you can reuse a module which has data already programmed into it. Why? How? Okay. You can do it because the Andromeda Research package will allow you to hook directly to the EEPROM part right here. And once you hook directly to the EEPROM part, you bypass the bus, you bypass the microcontroller, and you communicate and control, read, edit, change, program the data that's in the EEPROM. Okay, what that means is all you have to do is take a salvage yard or salvage yard module, and you can use one of our automotive kits, and you attach directly to the EEPROM in your failed module. You read it, and then you move the clip over to the EEPROM in your salvage module, and you program it. And then you install it, and then you're done. Because what you have done is you've taken the data, which is vehicle specific, from your failed module, and you've moved it into a salvage vehicle module. In essence, you've cloned it. So you don't need any special software. You do not need any special tools. You don't have to have subscriptions. You don't have to buy new software every year. But you do have to be able to identify the EEPROM in the module, and you do have to be able to operate our equipment, which lets you read and program. But honestly, the activity, the time that it takes to do this, once you've identified the EEPROM, is minutes. It's very, very fast. Okay, so there are some other things you can do. Not only can you do something as simple as what I've just described, which is cloning. Okay, basically you just clone the data from your defective module EEPROM into your replacement module EEPROM. Now the thing that you have to realize when you do that, the modules have to be the same part number. Okay, you can't just clone one EEPROM into another EEPROM if the modules are not the same. They have to be the same because there's a program that is running in the microcontroller, okay? And if the program that's running in the microcontroller is different, then you're going to have issues with proper operation of the module. So the modules have to be have the same part number. That's usually not a problem. Okay, other things you can do. If you have a module and let's just say you don't want to clone all the data, let's say that the only thing you want to do is change the VIN. All right, well, with the automotive kit, you can attach to the double EEPROM, you can read the information, you can see it on the screen, you can find the VIN, you can edit the VIN, you can program it back. All right, so you can change the VIN in the same module if you choose to do that. Another thing you can do is that if you happen to be able to acquire a brand new module from a dealer, you can read the information from the EEPROM, from the brand new module, and save it to a file. You can then take existing modules from salvage cars and program the information from a brand new module into those into the EEPROM in a salvage module, and you can perhaps market those to people that would be interested in not paying dealer prices for that module. Or if the module is not available because dealers don't have them in stock, you can become a supplier for those modules. So those are just some of the things that you can do with the automotive kit, and that's kind of the purpose of this video. So next thing I'm going to do is show you some modules from a Chrysler PCM. All right, here we have the module which I had before out of this out of a Jeep Cherokee, and in order to gain entry into this module, we had to bend all these tabs up. But then get the cover off, and let me zoom in here and just point out a couple of things. Okay, this is the processor. This is the big chip, and believe me, in a PCMs are not insignificant circuit assemblies. The amount of work that goes into engine management is significant. But vehicle-specific data is going to be, in most cases, unless they store it in the microcontroller, is going to be in an 8-pin EEPROM. So let me find it on here and I'll point it out to you. Okay, here is the circuit assembly with the electronics exposed. And one of the things that I want to make clear to you is that just because a part is in an 8-pin package does not mean it's a double EEPROM, does not mean it's a memory part. Okay, the 8-pin package is an industry standard package, and many different kinds of electronic components can be found in those packages: voltage regulators, operational amplifiers, things like that. All right. So I'm sure you want to know, well, how, if that's the case, then how do I find the double EEPROM? Well, I'll just show you. With all of our kits, you get this document, okay? How to locate and identify serial EEPROMs and microcontrollers found in vehicle modules and circuit assemblies, okay? So the purpose of this, and I'm not going to go over the whole sheet, but basically we show you pictures of the different kinds of packages. We show you how to connect to it with the different options that we offer. We have pictures that guide you in locating the double EEPROM. So this is part of what we provide in terms of training if you purchase one of our kits. All right, and we have EEPROMs on this page, and as I said, basically it's a document that provides that guidance. This is part of the education package that you get with our product. In addition, you also get a training tutorial with the real 8-pin EEPROM, and you sit down and you do exercises, and that's also how we teach you how to use our product. Okay, so on this particular circuit assembly, where is the EEPROM? All right, well, it is right here. All right, this particular part is a 25320 EEPROM. All right, so that's the part that you would have to attach to and copy if that's what you wanted to do. All right, so that's step number one. Let me zoom out here, and here is another module. All right, same kind, same part number, except this one is out of a Chrysler 200, but they're the same. And if you look on this module, you can see there is the same EEPROM right here. So all you have to do is connect to the first, your source EEPROM, read it, then move the connection option, whatever you use, the clip, the Accutouch probe, whatever probes, over to your target module, your salvage vehicle module, hook to this part right here, and you program it, and you install it, and you're done. Okay, at this point, I was going to proceed to show you physically how to clone one module into another. However, this video has exceeded 30 minutes in length, so what I've decided to do is move basically that procedure to another video. So we'll do another presentation where I actually show you how to clone the data from one module to another. Also, we'll edit the VIN, so you can see how that works. So I'm going to wrap this one up at this point, and there will be a part 2. So just stay tuned, and there will be another presentation, which is going to be part 2, so we can complete the exercise, and you can see exactly how our automotive kit allows you to perform the operations that we described in this video. So again, I'm going to wrap this up, and if you are interested in our products, you can get information from our website, which is arlabs.com. And if you have any questions, as always, we are happy to speak with you. So you can call us or email us. And again, we thank you for watching.